Hello class, so today we're going to talk about experimental design. Some of this is going to be a review from some of the earlier things that we've talked about, but then some of this is also going to be very new. So hopefully this will reinforce some of the things that you've already learned, but also help clear up any misconceptions about things you may be having, and also show you how to design good experiments. Okay, so what is an experiment? Well, an experiment is basically a method that shows how one or more variables relate to each other. And usually this is through some kind of control or setup where you can see whether the relationship is genuine or not, or whether it's a result of something else. Now, something to keep in mind when you're designing experiments and when you're coming up with research questions and dealing with quantitative style post-positivistic research is that you have to have two kinds of variables. You have to have an independent variable. Oh, we'll do yeller today. Okay, you have to have an independent variable, okay? And remember, your independent variable is the variable that's getting manipulated, right? So usually it's your x variable. And then you have a dependent variable, and that's the variable that's being affected, okay? And usually you call it the y variable. So the independent variable is the variable that essentially you're playing with, okay? So if you're wanting to study how communication apprehension relates to anxiety. So what you're trying to figure out is how is communication or how is anxiety affected by communication apprehension. So what you're saying is X is going to be your communication apprehension and Y is going to be anxiety. Okay? Now, it doesn't necessarily, so here's the thing, like one way of thinking about the independent-dependent variable relationship is the X causing Y, but remember, it doesn't necessarily have to be causal. Remember, we have correlations, so that's why it's somewhat of a good understanding to say, you know, the independent's kind of the cause and the dependent is the effect, but it's not necessarily true because it can also just be correlative, not causative, okay? But essentially, you need to have these two things in any kind of research question. Whenever you write a research question or a hypothesis, when you're dealing with experimental studies, you're generally asking, what's the relationship between X and Y, okay? So if you're just asking, what is X, that's not an experiment that we can really do in social science. Now that might be a good qualitative study or something like that, or exploratory study, but when we're trying to understand the relationships between variables and coming up with experiments to understand how those relationships work in a controlled setting, you generally have something like this. What is the relationship between X and Y? So you always need an X and you always need a Y when you're trying to design experimental studies. So how does this one thing in this world play with this other thing in this other part of the world? Okay? So that's one of the things that you have to understand about scientific research. Remember, the only things that exist are the things that we can taste, touch, see, smell, and so forth, right? So whatever it is that you're studying, it has to be in the world. Well, if it's in the world, then we can measure it in some way, because if we can taste it, we can see it, we can touch it, we can hear it, then there's some way of being able to measure that objectively, right? Not just, well, I feel like it sounds like this. No, there has to be a way that we can measure it so other people can see, oh, okay, we all understand how this is working because there's an objective measure, right? It's kind of like asking, how far away are you? I don't know, pretty far away. Well, that's pretty subjective, right? But if you can say 10 feet, we can all understand 10 feet. It's the same thing with social scientific phenomenon. So when you're trying to deal with like a variable like communication apprehension, you know, so it's a feeling, right? But we can at least get an understanding of that based on a scale of like maybe like a Likert scale, right? You know, strongly agree that whenever I feel like I'm about to speak in public, you know, I feel really nervous. Okay, we can understand that this person feels really nervous, so that's measurable, okay? So whatever it is that you're studying needs to be an X and a Y, and it has to be it has to be measurable in some way, quantitatively, because remember, we're doing quantitative research right now. So quantitative, the difference between quantitative and qualitative research, quantitative, you're dealing with numerical data, okay? And qualitative, you're dealing with non-numerical data. That's kind of one way to put it. So non-numerical So right now, remember, we're still in this, okay? We're dealing with numerical data, data that is a number, basically. So whenever you pick your phenomenon, make sure there's an X and a Y, an independent and a dependent. The independent's what you're playing with. The dependent is the effect or the thing that you're trying to figure out is related to the independent. And you want it to be something that can be numerically measured in some way. Okay? All right. Okay. So now let's go through the basic steps of the experiment process again. So the first question you need to figure out is what variables are under investigation. So remember, we just talked about that, your X and your Y. So you're trying to figure out which two constructs are you wanting to study. So communication apprehension would be a construct in the world, and it can be a variable. Anxiety can be a construct or a variable, right? It's a thing in the world that we're aware of. Privacy management could be a construct, okay? It's something in the world that people do, okay? Or self-disclosure or breaking up could even be a construct, right? It's something that's in the world that we can measure or we can learn about through some kind of measurement, whether through a survey or through an experiment. What data are being collected? So are you collecting, let's say if you're studying communication apprehension and the relation between that and public speaking performance. Okay, so what do you need to collect to learn about people's level of public speaking anxiety and its effect on public speaking performance? Well, you're probably going to have to do some kind of attitude measurement, right? Because communication apprehension is an attitude or a feeling that people have. So you'll probably have to do a survey of some kind. But then if you're doing the effects on public speaking performance, maybe you also want to have people maybe rate public speaking performances or ask the speaker afterwards to rate their own performance. So in that case, maybe you'll do another survey, okay? So you'll have two little surveys in your experiment. One about how you feel about communication, or how you feel about public speaking before you do it, and then maybe one afterwards about how you felt about the performance after you gave it. What is the source of your data? So are you going to college students? Are you going to public speaking students? Where are you getting your data from? Okay, so these are all kinds of questions that you have to figure out. And then how is the experiment being conducted? So what we're going to talk about today are different kinds of experimental designs that you can do. So if you weren't just doing surveys, but maybe setting up some kind of laboratory experiment where you have people come into a lab and maybe do something with public speaking and have observers watch, then that would be a possibility. You could also just do surveys, but we're going to try to expand our world now and learn about lab experiments. And then how will the data be analyzed? So that's what we've been studying the past 2 weeks. And remember, there's two kinds of quantitative analysis. Remember, there's tests of relationships, okay? And remember, those are your t-charts, or your dependent samples t-tests, your chi-square analyses, and that. And then remember, those are tests of relationship is correlation and regression. Sorry, I was getting ahead of myself. That's correlation and regression, okay? That's tests of relationships. And then test of differences is your t-tests, chi-squares, all of those. So your one-way ANOVAs, those kinds of things, your t-tests, all that. So what you've basically learned is once I've collected my data, what kind of analysis would I need to run to understand what to do with my data? And more importantly, the reason we've covered data analysis is more or less so when you read studies, you understand what they're doing and like what the whole point is. Like, what's this ANOVA thing? Okay, well this is what the ANOVA thing is. This is basically what's going on. Okay, so usually your experiment will come down to one of these two different tests. It's just depending on what you're interested in and how you frame your research questions. Okay, so let's go through the research process again. I know once again some of this is review, but I'm hoping to tie some loose ends up and make sure that everyone is on the same page. So remember, step one is preparation. And remember, you're identifying the broad research problem. So this is where you can say, this is the thing that I'm interested in. I'm really interested in how do people break up over Facebook, right? So maybe, you're trying to figure out what are some common ways people break up over Facebook and how does it affect people's ability to recover, okay? So does breaking up over social media affect how people recover from the relationships afterwards, something like that. Okay, so there you have somewhat of an X and a Y, methods of breakup, and which would probably be a nominal type variable, and then you would have ability to cope, which would probably be probably an ordinal type variable or interval, just depending on how you measure it. So there you have two variables, okay? So that would be that. Now, something to keep in mind is that there's a difference between descriptive and normative questions. Okay, so descriptive questions are about what and how, right? So what is this thing in the world? Or how do these two things in the world relate to each other? So descriptive is all about is. How is something in the world? What is this thing in the world? Or what is the relationship between these two things in the world? Normative questions are about should, right? What should we do about pollution in the world, okay? That's a normative question, okay? Or what's the best way for people to break up? That's a normative question because it's about should. What should people do? So in social science, we're interested in this. Normative questions really aren't ones that can be answered in a lab or in an experiment. The answer to normative questions are based on what happens in experiments, but usually the answer to a normative question is an extrapolation of an experiment, okay? So your research questions should never be should. Like, what should people do in this situation? Or what is the best form of blah, blah, blah? All of it should just be is. How is this thing in the world? What is the belief of this thing in the world? Or how do these two things interact? It should not be political in any way, okay? So keep that in mind as you continue developing research questions and hypotheses. These should be descriptive, or actually the better term even would be empirical. They should be empirical questions, not normative questions. Okay, then you write your research question or hypotheses. So when you're doing experiments, you'll usually do hypotheses. So you'll say the relationship between X and Y is X, you know. And then remember, you have two kinds of hypotheses. You have your null, your HO, which basically says no relationship. And then you remember you have your alternative. X and Y are positively correlated, okay? Maybe positively, maybe that's your hypothesis, okay? So that would be an example. So if we did public speaking and training, you might say the more training people get, the higher performance they get. The higher public speaking performance they report on a study, okay? So that would be an alternative or a hypothesis. So variable and method selection, remember you define your independent and dependent variables and you decide measurement. And remember, once again, it should be something that you can quantify, right? So you want to give an idea of how do you quantify your variable, because remember, quantitative research is about numerical data. Now you can still use nominal and ordinal variables, but you got to have some way of measuring it objectively, okay? In a way that other people can see, like, okay, I see what this person means when they say it was far away because they said it was 20 feet. We can all imagine 20 feet. If a person just says far away can mean a lot of things to different people. So what makes it objective is that 20 feet is an objective measurement. You see what I mean? So we can understand that. Then, of course, you design the experiment. And this is what we're going to talk about today, is experimental controls, different groups and assignments and tests. So we've already done this. We've already done that. And then we will also learn some of this today. And we've already learned how to analyze the data. So essentially, we've done all the steps except this. So probably in the future, I'll probably go in order. But, you know, I think this will all help. Doing this at the end helps you see the big picture as a whole. Okay, so let's talk about experimental control. So there's two aspects. First, there's experimental control itself. And this is ensuring that you've controlled for alternative variables and effectively manipulated the independent variable. Okay, so essentially what you're trying to make sure is that when you're trying to prove a relationship between X and Y, that you know, you make sure that there's nothing in between coming. There's nothing else that's coming in between them. You see, there's not like an A or a B variable like somehow affecting this relationship. What you're trying to make sure is that it really is just a test between X and Y and not X, A, and B, and Y. See what I mean? So you're trying to make this clean as possible, not affected by anything else. And then you have manipulation checks. And what this is making sure is that your change in X had actually an effect on Y. Sometimes like you didn't do enough to make X have an effect on Y. So you have to make sure that that X actually did cause an increase or actually do something to your sample so that Y could actually be affected. Because, for example, let's say let's say your training was so minimal that you just didn't give your sample enough time to learn the class, or it was given in a rush when it normally wasn't. So then X wasn't really changed all that much. So then you would think, and then there's no relationship between Y, and then you conclude, well, training didn't obviously work. Well, what might have actually happened was the training that you did for the experiment maybe was a very short version of it, and it wasn't like a real test. And so X didn't have enough time to be affected by training to then be affected by Y. So you have to make sure that you've done enough of X to where Y could have actually had an effect, okay? Or to where it could have actually had an effect on Y. That's what a manipulation check is. Okay, so now what we want to make sure is technically when we do an experiment, there's three ideals, if you will. Like the ideal experiment would have these three things, okay? First off, it's going to have comparison groups. And comparison groups, there's two sets of them. The comparison group itself is the group that's exposed to manipulated levels of the independent variable. You've also might have heard of this. It's also sometimes called a variable group. So if you have two groups of participants, one group is the group that's exposed to the variable. So let's say we're doing public speaking and communication apprehension, public speaking class and communication apprehension. The variable group is the group that actually gets the public speaking class. The control group would be the group that doesn't get the public speaking class. And so what we would do is we would compare, the control and the variable group, and we would say, okay, the control group doesn't get a public speaking class, but the variable group does. So what's the difference in results between the two groups? Okay, so ideally, an experiment will have two groups to compare to. The other ideal that experiments should have, or we would like them to have, is random assignment of participants to groups. So what we would like it to be is where you could have the population or your sample randomly assigned to a control group or a variable group, okay? And the reason you want it randomly assigned is because if you just take a group that's already pre-existing, then there's a chance you could have bias in the groups, okay? So, let's say I was doing a study on athletes, and I said, okay, it's just easier to study the football team as one group and study the soccer team as another group, and we'll just have those be the two comparison groups. The problem is just that if it's not randomly assigned, like if you didn't take all athletes and you mix football players with soccer players and mix in one group and mix football and soccer players in the other, it's just that there are natural differences between the football players and the soccer players, just by the fact that football players are probably maybe bulkier, bigger, taller because they have to for their sport, versus soccer players, they're probably not going to be as big and tall, but they're going to be more lean. And so those differences alone can automatically create differences in your experiment and then not make them valid comparison groups, if that makes sense. Unless for some reason you're interested in the differences between football and soccer players. Okay, then that would be okay. But ideally, you would want your groups to be randomly assigned to each to account for natural differences that would be there if you just picked pre-existing groups. Okay? Then you have pre-test and post-test measurement. So ideally, in an experiment, you would have a pre-test where you measure the dependent variable before the manipulated independent variable takes effect. So if we were to start drawing these out, so you would have your control group. Here, let me put this here. So you have your control group and your variable group. So ideally, before you have anybody take my public speaking training class, let's say we're going back to public speaking and communication apprehension. Ideally, before you even do the experiment, you should take an observation of how people are reporting communication apprehension and their public speaking performance. And then you run the experiment on the variable group, okay? And then you take another observation, and then you have a pre and a post test, okay? So that's what the post test is. It's the measurement of the dependent variable after the manipulated independent variable takes effect. Or excuse me, measurement of the dependent variable after the manipulated independent variable takes effect. So this is the pre-test. This is the experiment, okay, right there. And then this is the post-test. So there are three things then that the experiment should have. It should have comparison groups, the control and the variable. Randomization would be randomly picking a control group and a variable group, and randomly picking a control group and a variable group and randomly assigning people. Then doing a pretest of some kind, the O1, the O1, then the experiment, and then the post-test. Okay, so that way you have a way of measuring what happened before, then having a way of seeing, okay, and then this is the thing that took place, the treatment, and then you have a way of measuring, okay, now here's what happened after. Okay, and we randomly assign groups, so it's not a result of just group differences. And we had a control and a variable group, so you can see that things were different when we had the treatment versus not the treatment. So those are the three ideals for experimental control. Now, here's the thing. We can't always do this, okay? We can't always have the ideals. You know, you can't always get what you want, right? Just like the Rolling Stones, okay? So sometimes we have to settle for what's more practical, okay? And so here are some other kinds of designs that basically miss one of the three ideals of experimental control, but are still valid for some purposes. And so these are the three different kinds of non-ideal experiments that are still out there that still get used, and we'll explain when they're used and so forth. Okay, so the first group is called pre-experimental designs. Okay, and pre-experimental designs are designs that lack a control group. So remember, an ideal experiment should have comparison groups. Okay, and pre-experimental designs, they don't have the first criteria. They don't have a control group. So here are two common studies or designs that would use this, that would look like this. So first you have the one-shot case study, and this is where the measurement of the dependent variable is taken after some manipulation of the independent variable, okay? So if we were to draw this, okay, you would just have one group. So let me explain some notation just so it's easier. So when we have O1, that's the pretest. O2 is the post-test. Then we have X is the treatment or the intervention, whatever it is that you're doing, whether it's the training, a pill, whatever. Let R be randomization. This is just notation so you can understand my charts. R is randomization, and then C is the control group, and then V is the variable group, or the comparison group. I'm just using V because it's easy, because two C's is too confusing. Okay, so if this was our little symbology here, okay, so a one-shot case study would just be this: treatment, post-test. That's it, in one group, okay? And so you can just call it the variable group. So the variable group, treatment, post-test. So where might we use this? Well, if a class, like let's say my public speaking training course, didn't take a post-test of people, we only had one class, okay? And so all I did was I gave the course, and then I just asked students afterwards, so did this improve your public speaking? And everyone said yes. Okay, so that's like a one-shot case study. There isn't a pre-test where we can kind of objectively measure like how things improved. It's just kind of like, here's the treatment, how did it work for you? Okay? We don't really know anything about you beforehand. We don't have a control group to see like how much progress we've seen. It's just whatever. Political consulting groups will use this. This how effective a political campaign has been. So they'll just bring in some random voters and say, what did you think of this commercial that we just showed? And most people will say, I guess it was pretty good. Okay, so that's a one-shot case study. It wasn't kind of like, here's how I felt about Donald Trump before the ad, and here's how I feel about him now after the group. If it's just, here's the ad, how do you feel about Donald Trump? Okay, well then, that's your one-shot case study. You can also do a one-group case study, and the only difference here is you're adding a pre-test to the one-shot case study. So this is what you would have. You would have a pre-test, then your treatment, then your post-test. Okay? So maybe we'll show you an ad, and maybe before, we'll have you take a measure, an attitude measure about how you feel about Donald Trump. Okay? So before you come to the little focus group, the little PR focus group, and they're like, we want to know how to improve Donald Trump's campaign. Fill out this survey about Donald Trump. How do you feel about him? You're like, Donald Trump is a nice guy. Strongly disagree. Okay, great. And then you have your treatment. So then they show you the campaign ad with Donald Trump, doing whatever, being Donald Trump. And then they have you take a test again. Okay, now how do you feel about Donald Trump? Okay, so that's a one group case study. And there's a pre-test, the treatment, and the post-test. Okay, so that's a pre-experimental design. There's no control group, so we don't know people who hadn't seen anything about Donald Trump, if they hadn't seen the ad, how would they feel about him? And so the problem is just that time can be a variable. Like sometimes people warm up to the idea of Donald Trump. So maybe the fact that 5 minutes went by, maybe I feel better about Donald Trump now. That's a possibility. Time can make people more open to something. So that's the reason pre-experimental designs are also limited. Because you don't have the control group, it's hard to know like what's actually a result of this and what's just actually a result of just natural progression of things. So then you have quasi-experimental designs, okay? And what makes quasi-experimental designs quasi-experimental designs is that they don't have random assignments. So remember, control groups, random assignments, and pre-test, post-test. So these, they don't have random assignments. So here's a couple of designs that are out there. Here are the most popular ones. The time series design will run a pre-test and multiple post-tests over a period of time on a single group. Okay? So, and technically it can be pre-test. You can run multiple pre-tests over a period of time on a single group. So what you're trying to do is you're trying to measure the dependent variable at various points in time to assess degrees of change in the dependent variable over time. Okay? So this is how it might look. So, you might have just a variable group again. So you might still lack a control group, but you just have pre-test, treatment, post-test, post-test. So maybe if you're doing marital happiness, okay, over time, or if you want to do the Donald Trump thing again, let's have people take a pre-test 6 months before we show them the ad, and then let's have them do a pre-test 1 month before the ad, then let's show them the ad, then let's do a post-test after the ad, 5 minutes after the ad, and let's do another post-test, 2 months after the ad to see if it had staying power, okay? So that's a time series design. What you also can have, and I'll erase this, is a non-equivalent control group design. And basically it compares two groups that are very likely to be different before the study even begins, okay? So here you might have something like this. You might have a control group, and you have their pre-test, post-test, post-test. Then you have the variable group, or actually you don't have the treatment there. And the variable group, there you have the treatment and the post-test, post-test. So here you have a control group, and you're looking at pre-test, over time, then post-test without the treatment. Now, it can be somewhat misleading to leave this blank because it may not be that you don't do anything to the control group, but maybe you do like a placebo or something that's normal. And then with the variable, you'll have the pre-test, then the actual independent variable or the intervention that you're making, and then the post-test. So if we were doing my public speaking training course and communication apprehension, we would have one group of people who just have who just do pre-tests over 6 months. So maybe we pre-test them 6 months or 1 week into the course, 2 months into the course, and then 3 months into the course, 4 months over the course. Okay, but let's say for the variable group, the group that I teach, 3 months or 4 months into the course, 3 months into the course, then my actual course, and then 2 months, and then 1 month. Or so I guess it would be before the course. So this would be 2 months before the course, 1 month before the course, then my actual course, then 3 months in, 2 months in, something like that. Either way, what's going on is you're having the treatment, and here you're not. Okay. Here's the thing. So when you say that the groups are very likely to be different before the study even begins, what this means is that your groups weren't random, remember? So yes, you have a control and a variable group, but the groups might have already been different by nature. So with my public speaking training class, if I just picked 2 classes, so like if my way of getting my sample was, I'm going to take Miss Scott's class, and then we're going to take the honors public speaking class from Miss Clark, and we're going to compare the two. Well, if one of them is the honors course and one of them is Miss Scott's class, there's probably going to be natural differences between these two, right? Because one's the honors course. That's going to be self-selected, go-getter students, whatever. And Miss Scott's class, it's going to probably have normal students in them, okay? And even if I did something like Miss Clark's class, even, there could still be some natural differences between the two, because maybe some people naturally self-select into Miss Scott's class and some people naturally select into Miss Clark's class. Maybe some people hear Miss Clark's class is really easy, so all the students who are just like, I just want an easy class, do it, and maybe they have personality differences, and maybe people hear that Miss Scott's class is really hard, so then all the students that want challenges are doing her class, you see? So the two groups are very likely to be different before the study even begins, okay? So that means that they're not equivalent, okay? But you can still get roughly an idea of what might be working and what might not be working, but sometimes it's not possible to randomize for some reasons. So there you would have a non-equivalent control group design. Then you have the true experimental designs, okay? And so these are ones that employ all 3 criteria of an ideally controlled study. So there's a couple ones. You have the pre-test, post-test equivalent group. And so this has the pre-test, post-test. That's one of them. It has the comparison and control groups. And it has random assignment to assess the effects of an independent variable on a dependent variable. So here's how it would look in notation. So you have your control group, randomly assigned. And then you would at least have one pre-test, and then you would have one intervention at least, and then one post-test. All right? So that is a pre-test, post-test group, equivalent group. So this is ideal. This is kind of what we would hope, but things happen. So it's equivalent to the non-equivalent control group. So it's even the same, it's kind of the same as what we looked at last time in the last slide, except that it includes random assignment of study participants in either comparison or control group. So if we were to do that public speaking experiment again, and instead of doing it by class, if we just said, I'm going to take a couple of I'm going to randomly select public speaking students from all of the instructors and put them into a mega class, if you will, then that would be a bit more random than just saying, Miss Clark's class is participating in my program and Miss Scott's class isn't. Instead, I'm randomly selecting from each group and putting some in the control and some in the variable. Another is the post-test equivalent groups. And this has everything from the previous except a pretest measure. So essentially what you would have, you'd have a control group and a variable group. You'd have random assignments, but the only difference is in the control group, you'd have a post-test. In the variable group, you'd have treatment in the post-test. So there's no pre-test, there's no O1 in this, okay? So that would be an equivalent of a post-test equivalent groups, okay? And so it's kind of like the almost like the one-shot case study, except it's randomized. And, you know, we just ask people, how do you feel about this treatment? Oh, it feels pretty good. Okay, so we notice an improvement, and we can compare maybe the differences in improvement between the two groups versus the people who didn't have treatment. Okay, so randomly assigned groups, give one treatment, give one not, and then see how they've improved and compare the differences between these two. And then you can do a test of differences, right? So now you can do a test of differences, you can do a t-test, whatever, and whatever. There you go. Now you can analyze the data. So that's putting it all together for you. Then lastly, you have the Solomon 4 group design. And so this is basically the true experiment on steroids. So what you essentially have is you have 2 control groups and 2 comparison groups and everything else of a true experimental design. And so this was a lot to draw, so I just Google image searched this, so I'll run you through it. So you have experimental group 1 and control group 1. And so you have randomization, so that's the R's there. And then you have experimental group 2 and control group 2. Now, why would you have 4 groups? Well, here's the idea. So notice here we have 2 pre-tests, but 2 of them don't. So group 2 has no pre-testing. That's missing. So experimental group 1, you know, the variable group gets the treatment. Control group doesn't. Experimental group 2 gets the treatment, and the control group doesn't. And then you have period 2, which is where they have all the post-tests. Now you can just ignore, like, you can just make all of these 1, so I'm going to use black here. You can make all of these 2, so don't be confused by the O, 3, 4, 5. All of these are O1s and O2s, basically. You know, X's and O, O, O. Okay, anyways, so these are O's and O's 2s. So the question is, why do you still need 4 groups? Well, here's the idea. The argument is when you do pretest, you necessarily sensitize people to the process. Because think about it, if I had people take a pretest on the ACT, and then I gave them an ACT training course, and then I had them take it again, the problem is when you pretest, you sensitize people to the ACT naturally, right? So in experimental group 1, they had a pretest, then they had the treatment, and then they had the post-test. And control group 1, they had the pretest, they had nothing, and then they had the post-test. Well, maybe just from the pretest alone, that caused improvement. And maybe from the pretest alone here, that caused improvement. It's hard to know. So what you do is you have an extra set of groups where none of them get the pretest, okay? So that way there isn't the, well, when you pre-tested them, you necessarily made them better the second time because they had experience, you see? So that helps you more clearly delineate the effects of the testing itself and the actual treatment that you did, okay? So that's the advantage to the Solomon 4 group design, is just that you can also account for the effects of pre-testing, because pre-testing in itself can necessarily change things, right? So it's kind of like the Heisenberg uncertainty principle. You know, whenever you study something or look at something, you necessarily change it. So this is what this is trying to solve for, okay? And, you know, Heisenberg was a good physicist slash chemist, okay? And he was also the name of the guy on Breaking Bad. All right, let's keep going. So, threats to validity. So, there's 2 kinds of validity, by the way, and I don't think I explained this, so let me explain. So, there's 2 kinds of validity. You have external validity, and you have internal validity. Internal validity is, does the experiment measure what it's supposed to measure, okay? So, did you adequately test public speaking? So, if we were doing the public speaking performance and training, right? Did I actually study, like first off, did I actually really train my students, and did I actually really improve public speaking and performance, right? That's internal validity, because maybe all of the improvements are a result of something else. Maybe it's just the fact that, you know, people naturally get better at things, or people do extracurricular studying when they're not in my class or whatever. That's all internal validity problems. External validity is all about how applicable or how realistic is this study to the actual outside world, okay? So applicability. So applicability has to do with, so if we come up with an experiment, but we have all these controls in it and whatever, even though we might be able to really solve for internal validity, the experiment itself might be so controlled and faked that it may not have any external application because the environment that was done in was so artificial, like that wouldn't really be how it works in the real world, okay? So the idea is that internal and external validity trade off from each other. So the more internally valid you are, the less externally valid you are, because you've basically made the environment so artificial it's unrealistic. But at least you have a better understanding of your variable in that setting. If you try to make it super externally valid in real world, it's hard to control for internal issues. Okay, like how do you know you're really studying what you're studying? Because you're in this open world environment where anything could be affecting anything. Okay, so that's the two kinds of validity. Okay, so one set of threats to validity is time progression. So you have things like history, so things that are occurring during the experiment that's outside the study but may affect the outcome of it. So, you know, maybe you're doing a study on communication apprehension and you're doing this public speaking training, but perhaps while you're studying your participants, some of them have depression, you know, or something. Mom and dad are getting a divorce in the middle of their college career, so that's affecting how they're able to perform in the study because, you know, they can't stop thinking about mom and dad, okay? And so it affects how well the training works, and it also affects public speaking performance. Instrumentation is where the instrument is changed during the experiment. So maybe while I'm giving my public speaking training course, I make some changes to the curriculum for one group because I'm trying to adjust to them. That would be instrumentation. Or researchers running surveys on people and they decide they need to change 2 or 3 survey questions for a different group because they keep messing up or something like that. So instrumentation is where the instrument gets changed in some way. Then you have maturation, just naturally occurring process in experiments. Look, people get older, people get smarter, people get more experienced. So that's always a possibility with public speaking training, right? It's just that people just naturally get better at public speaking anyways, just by coming to class, because, well, people get older, smarter, you know, quicker, all that stuff just by nature alone. So that's maturation. Same thing with drug trials, right? Some people just naturally improve just because their immune systems start to take off, okay? So that's maturation. Mortality, it doesn't necessarily mean people dying, although that is possible in medical studies. You know, you're running a new treatment on a terminal illness. Some people just, you know, die, you know, so that's a problem. But with more social science studies, you shouldn't be killing anybody for social science studies. So your issue is just more or less like if you're doing a time, you know, a longitudinal study, just you lose 2 or 3 participants because they got too busy or they just quit responding to your emails or whatever. That's mortality in that case. I know it sounds very mortal, but you know what I mean. Then you have testing sensitization. And so remember, that's what the Solomon group 4-group design is trying to solve for. And that's basically pre-testing is sensitizes your group to the whatever it is that you're studying. And so they necessarily do better on the post-test because they've been pre-tested, so they understand what to do. So remember, that's what the Solomon 4-group tries to solve for. But the problem is we can't always do Solomon 4-group design on everything. That would be nice if we could, but for practical reasons, because funding, or it's not possible to get 4 groups, or because you can't do pre-tests, not everything is pre-testable. Like, break up with your boyfriend as a pre-test, then we're going to do this experiment, and then break up with him again. Like, and then, you know, like you can't do that, right? You can't have a pre-test and a post-test for how you break up with your boyfriends or girlfriends, right? You can't pre-test them and then, you know, okay, now we're going to do it for real. Okay, now how do you feel? Okay, so you just can't do that. That's an issue. Then you have reactivity effects. And so these are threats to an experiment that center on the responses design, the participants to the design of the experiment. So these are participants responding to the experiment. So time progression is factors outside the experiment. Reactivity is inside the experiment, and it's usually participants. Okay, so here are some ways that participants can create reactivity effects and hurt the validity of your experiment. So compensation behavior is when the control group finds that the comparison group is being treated differently than they are. So if there's some kind of interaction between your control group and your variable group, and like the control group figures out like, hey, the variable group doesn't have to take this public speaking course, what's up with that? They may get upset, or they may, start noticing differences. Oh, that's what they're studying. Okay, I see. That's the next one, demand knowledge. This is where participants provide answers that they think the researcher wants to hear or know. So researchers try to make it, see, the thing is, like with IRB, you have to tell people what you're studying, but you have to also not be so upfront about it too, because it's like, otherwise people start to provide answers that they think you want to hear, okay? So in the Stanford prison experiments, that's exactly what happened. So remember the Stanford prison experiments where Zimbardo had the kids go and create a fake prison, and then it got all out of control because they started beating the prisoners and all that stuff. In the first 3 or 4 days of that study, like when it first launched, absolutely nothing happened. Like it was boring, right? The kids just stayed in their cells. They just laid around. They didn't do anything. Well, then one of the participants was like, I think they want us to do something. Like I think the point of this experiment isn't just for us to lay around. I think what they want us to do is rebel. So that's exactly what they did. They put their mattress against the jail cell door, and that's what led to the guards starting to crack down, and that's what caused it to get out of control, and the guards beating the kids and all that stuff. So that's demand knowledge. They realize that, hey, they're in a study. The researcher probably wants them to do something. What is it? What is it that they're really trying to study? What can I do to help the researcher, or what can I do to mess with the researcher? All of that is demand knowledge. Then you have experiment apprehension / excitement. So this is when people are nervous about being in an experiment. So, if you were in a lab and people are like, tell us about your deepest, darkest fears, right? That could create nervousness, and maybe you won't say what's on your mind, or, you'll put up the walls. Or maybe you're really excited about being in the experiment, and then you're just kind of like, yeah, I want to do this, and then that can cause issues with validity. Sometimes researcher attributes, so your personal traits as a researcher could throw people off. So a lot of times when you're doing studies that, like studies of like rape victims and such, it's better to have probably female researchers, just because, they're more trustworthy probably on those topics when you're trying to recruit women who have been, sexually assaulted. So, if you have a bunch of men in there, it's just kind of may not be good for some people. Then non-random selection, and this is just where you can't randomly select your groups. Okay, you can't randomly select your participants, or you just don't want to randomly select your participants, so you just do convenience samples. So once again, if you're to be representative of population, your sample has to be randomly generated. Okay, if you just pick what's convenient, that may not necessarily be reflective of what the actual population makeup is of your people that you're trying to generalize about. And then you have treatment diffusion, and this is when participants in the control group try to tell the variable group things about what's going on, okay? So, basically your control group and variable group are all talking to each other, and that influences how the control group acts, okay? Or how the variable group acts, because they're all conspiring, telling each other, this is what the experiment did with us. Well, this is what he did with us. Oh, so what they must be doing is this, this, and this. You see what I mean? So treatment diffusion can be a problem. I know it sounds very like chemistry, physics, but we all like to, for some reason in social science, people want to sound all like it's physics and chemistry, so that's what you get. You get reactivity effects, that's what you get, and treatment diffusion. Okay, so that's pretty much it for experimental design. So hopefully this gives you a greater understanding of how experiments are designed, what the names of them are, and how you can design better experiments in your future assignments. So if you have any questions, let me know.